So what is some history from the Mad Lab?
The Mad Lab was first created when I got my first real teaching position, and I got it at Mount Allison University in New Brunswick. When I moved out there, I created my own Dendrochronology Lab and started the Mount Allison, or MA, and made the Mad Lab. And at that time, we were looking at past climates and climate research. But in Atlantic Canada, the forests are very young, but the built history, the churches, the houses, the sheds, the barns, they're very old. And they contain most of our old growth forests. So we ended up doing a lot of dendroarchaeology, actually working with archaeologists, understanding some of this oldest buildings in the region, and through that we got the ring patterns that I needed to do dendroclimatology, or looking at past climates. In 2013 I got a new job offer and I came back home to the University of Saskatchewan, and I kept the sort of the Cree tradition of Mistik, which means wood or trees, and Askîwin, which talks about time. So I used the MA there to keep the Mad Lab going, and I was the Mad Lab, the Mistik Askîwin Dendrochronology Lab. And we now do tree ring analysis of different sites, looking into ecology or forest ecology, archaeology still, climate change and climate aspects from coast to coast to coast. We worked on everything from the oldest hockey stick in Canada and pieces of the Titanic to northern tree line dynamics and ecology in the boreal forest.
So where did all this come from? I mean, this place has only been around for a dozen or so years, but it has a long, long history. It actually started way back in the 1950s, when there was a lot of work going on here that looked at the radiation impact when we were trying to improve how we would treat people with cancer. And of course, many people don't know that the very first cobalt-60 therapy for cancer treatment was actually done here in Saskatoon. From there, the thought was we should build better machines, and so they started in the 60s, in the 1960s, actually building what is effectively the foundation of this facility. And that was completed, and there was a lot of research done through the 70s and the 80s and the 90s and what was called the Saskatchewan Accelerator Laboratory. What did they do? Well, they built machines like this, and they became world famous for them. And so we end up with what we have today, built from 2000 to 2005, brightest light in Canada, but effectively going back, right back to the 50s, when Saskatoon was actually building the best equipment of this kind in the entire world.
What will the students gain from the tree project?
I think the students will gain quite a few things. They'll be able to understand some of the science, the deep science that's going on. They'll be able to try it out and test it to see if they like it. Will they go on in science in the futures? The individual teachers will help. We hopefully will cross a lot of curricular boundaries, so they'll be able to teach some of these aspects of the tree program, and they'll be able to use it in their classrooms without having to change their curriculum too much. And the individual students and teachers will be able to study areas from one side of Canada to the other. We're going from coast to coast to coast for a reason, so that someone in one coast, like at Halifax, can study another area in Vancouver, and they can learn a lot about areas in Canada that they wouldn't have normally.
What will the CLS gain from the tree project?
The CLS is going to gain quite a bit in the sense of it's a one-shot facility in Canada. It's the only one of its kind. And they have to share their knowledge and disseminate their knowledge, and they have to do that all across Canada. So by having this educational component that all these school kids from across Canada will be able to share with, they'll bring some of that taxpayer money that's gone from all over Canada into this facility, and they'll be able to share it. They'll also be able to break some new ground, look in some of this time mapping techniques that they'll be able to do that hasn't been done anywhere else in the world. And these school kids will be able to share in that, and the CLS will gain a lot by trying some of these new techniques.
And lastly, what will the Mad Lab gain from the tree project?
The Mad Lab and myself were really interested in that ecological plasticity. It's a fancy word to say how wide can all these different environments where these trembling aspen grow, from the desert-like locations, or the wet coast, or a high mountain, or a very cold location in Canada. We'll be able to study them all. And we'll also be able to look at the toxicology, that ability for those aspens to take up toxins in the soils or take up even elements through the soils and into their rings. This is something that's not really well understood. And aspen is used in this kind of environments to kind of suck up some of those poisons that people have put in the environments. And the trembling aspen might be a great remediation tool, a way to clean up the environment. So our overall hypothesis is to look at the toxicological and ecological plasticity of trembling aspen across all of Canada.